Alright, so this is Algebra 2, Chapter 5, Section 2, Polynomial Zeros. Alright, so we talked about polynomial in the form of a to the n plus n minus 1, x to the n minus 1, etc., etc. And they talk about the different zeros here. And the four different ways you can sort of think about a zero. They're equivalent statements. One is it could be x minus b equals 0, where b is the constant that you use to replace x, which will give you that 0. So that's one way of thinking about a 0. Another way of thinking about a 0 is it says b is the 0 root. So once we find what b is, we can say that b is that 0. For example, let's say we have x minus 3. Well, in order for this to be true, x would have to be 3. So we would put 3 here and say 3 is the 0 for that particular function. It says b is a root or a solution to the polynomial equation of p of x equals 0, what we just said. X minus b equals 0, so that's the equation. B would be the solution to that, which would make it 0. Or you could think of it as an x-intercept, the place where it crosses the x-axis is also the root. So these are all different ways to consider and think about what a root is or a 0 is. If they give you, it says what are the zeros of x, and graph the function. So I'm not going to graph it. So it says y equals x minus 3, x plus 5. Okay, so we have that. They all have to equal 0. So we could think of this sort of individually. X equals 0, x minus 3 equals 0, and we could think of it as x plus 5 equals 0. And the reason being is that if I plugged in the answers to those, they would all equal 0 regardless. So one of the answers clearly is x equals 0. The other answer would be x equals 3. And the other one would be x equals negative 5. If I plugged in 0 here, 0 times x minus 3 times x plus 5, it doesn't matter what these two guys are, because it's going to still end up equaling 0. So I'll plug in 0 here, plug in 0 here, it'll be 0 times negative 3 times 5. And again, it doesn't matter because it's already going to be 0. So that works. If I plug in negative 3, or 3 rather, 3 times 3 minus 3 times x plus 5 equals 0, then it's going to be 3 times 0 times 8. That's going to be 0. So that works. And then if I plug in negative 5, it'd be negative 5 times negative 5 minus 3 times negative 5 plus 5, which gives me negative 5 times negative 8 times 0, and that's going to give me 0. So those all work. Doesn't matter which one of them. These are all the potential zeros for this particular function. So when we plug these in, we already know what the coordinates are going to be. It's going to be 0, 0, 3, 0, negative 5, 0, because they all cross the x-axis. So we have points. In terms of graphing this, what they want you to do is put this in number order. So we have -5, -4, -3, -2, -1, 0, 1, 2, and 3. So we already know our x's is -5, 0, and 3. What they want you to do is to pick any point in between that so that it can set up our graph. So choosing like a -3, choosing, I'll probably do 2 more points, a -1 just to see what's going on here, and then a 2. And then plug those in and then graph it. If I was to use -3, it would be -3 times -3 minus 3 is -6. -3 plus 5 is 2. So that would be 18 times 2. That would be 36. So this would be -3, 36. If I was to choose -1, it would be -1 times -4 times 4. 4 times 4 is 16. So that would be -1 and 16. And then 2 would be 2 times 2 minus 3 is -1 times 2 plus 5 is 7. That would be -14. So you know when I graph this, -336 is nuts. So by -5, 0, 1, 2, 3, 4, 5. So I'm not going to do this to scale. My -3 way up here is going to be 36. Way to the sky. And then -1 would be 16, so say like around here. And this would be 0, 0. So 1, 2, 3, and 2 is what, -14. It's like somewhere around here. And then 3 is 0, so around here. So it would look roughly something like that. Again, this is not to scale, so, but it would be something where it's going to be a down and up because it's a positive x cubed function, and it's going to go up, hit some type of top, come back down through the origin, hit some type of bottom, and then come back up again. Or roughly like this, actually, coming up, coming down, going back up again. Okay. The factor theorem, expression of x minus a is a polynomial factor if and only if a is the 0 of the polynomial term. That just means that we can set x minus a equals 0. And it would only work as a factor when x minus a equals 0. That's all that means. With that information in mind, we can set this up. If they give us here they say we have a quadratic equation. Alright, and it says we have zeros at 3 and we have zeros at -3. Well, since I know it's going to be in the form of x minus a to equal my 0, I'm just going to replace that a with that number. A equals 3 and a equals -3. So when I set up my factors, it's going to be x minus 3 times x plus 3. And they want it to be they said a quadratic polynomial, so I know these are conjugates. So it's going to be x squared minus 9. So that's my equation for that guy. Then they give us another one where it's 3, 3, and negative 3. So we already established that if it's 3, it's x minus 3, and if it's negative 3, it's x plus 3. So when we do this one, I'm going to do x plus 3 times x minus 3. Since we have 3 twice, there's 2 zeros at 3, so we're going to say x plus 3 again. I already know that this is x squared minus 9. So this will be x plus 3. And then I FOIL, that's x squared, cubed, sorry, plus 3x squared minus 9x minus 27. So that's the equation of this line, just knowing what the zeros are. Okay. They want us to graph it. We'll graph them on Desmos. Where's my Desmos? Okay. So here's the x squared minus 9. It's a parabola. And then there's the x squared minus 3x squared minus 9x. Wait, is it plus 3x or minus 9? Oh, plus 3x. Let me fix that. Okay. When we set that up, it's going to look like this. One is a quadratic, hits the zeros at 2 spots. This is a cubic function because it has x to the 3rd power. And it's following the down and up. So it's going to here to hit the 0 at 3, coming down here, and hitting the 0 at positive 3. So remember, there's 2 zeros at 3, so what happens is that when we have a 2, 0, it has a multiplicity of 2, meaning we're going to deal from 3 to 3 is going to be sort of acts like a quadratic. And we'll talk about that actually right now. Alright, so if we have a situation, and the book has it here as f of x is equal to x plus 2 times x plus 2 times x minus 3, we have 3 zeros. We have a 0 at negative 2, we have another 0 at negative 2, and we have a 0 at 3. Here we have what they call multiple zeros, meaning that it occurs more than once. And the number of times that it occurs actually is important in helping us graph and sort of figure out what the graph might look like. Since we have multiple zeros and it occurs twice, we would say that this function has a multiplicity of 2. And what a multiplicity of 2 means is that it's going to act in a particular way. So if you have, and 3 has a multiplicity of 1. So negative 2 has a multiplicity of 2, and 3 has a multiplicity of 1. What does that mean? If you have a multiplicity of 1, it behaves similarly to like a line. If it has a multiplicity of 2, at that 0, it behaves like a parabola. So here's what this means. So here we have this function, and it says it's x squared times x plus 2 minus times x minus 4. Here's something you need to know. When you have an x squared, we can say that it's x minus 0 times x minus 0, which is true. We have a 0 at 0. That the number is 0. or root at 0. When I do FOIL, this is going to be x squared minus x times 0 minus x times 0 plus 0 by, and that just gives me x squared, so it works when we simplify it. So we have a 0 or a root at 0, and it has a multiplicity of 2. Alright, so when we go, so thinking about that in mind, we have x squared, x plus 2, x minus 4. So we have 2 roots at 0. This has a root at -2. This has a root at 4. 1 root. Since it has 2 roots at 0, this one has a multiplicity of 2. This one has a multiplicity of 1. This one has a multiplicity of 1. When we have a multiplicity of 1, these guys behave like a line at the root. When we have a multiplicity of 2, this guy behaves, when we graph it, like a parabola. So when we graph these guys, right here, here's the root at -2, and it's behaving like a line right here, from here to here, behaving like a line. After we go to -2, and it gets to the second root at 0, look how it's happening. It's behaving here like a parabola. It's behaving like a parabola. Then we go back down, and then when we get to the third root at 4, here it's definitely behaving like a line. So it's acting like a line here, acting like a line here, acting like a parabola here. And that helps us. That helps us when we do graphing and giving us an idea of what it looks like before we even get started. Alright, it says here, what are the zeros of this function? Squared plus 4x. Okay, what are the zeros? X. So we can factor out the x, and this would be x times x squared minus 4x plus 4. What's this? This is going to be x times x minus 2 times x minus 2. So we have zeros, or roots at 0, 2, and 2. So we have 2 roots at 2, so it's a multiplicity of 2. And this one has a multiplicity of 1, so it's going to be a cubic, because it's to the 3rd degree. So, and then we will have a root at 2. So, it's going to behave like, it's going to act something like this, right? Since it's a quadratic, so it's going to be down and up. So we have a root at 0. So it's going to do like this. It's probably going to do something like a root at 2. So it's going to probably do something, I'm guesstimating, it's going to do something like this. At 0, and then at 2 is going to go up like that. Something like that. This, at 1 is going to behave like a line. At 0, then come back down and behave like a parabola down here and then go up. That's my guesstimate. Okay? And again, it helps us draw the line. And a matter of fact, let's see if we can, let me add that one. So it's going to be x cubed minus 4x squared plus 4x. So x cubed minus 4x x squared plus 4x. Okay, so let's take a look. See, I was going to go past. Okay, that was close. So it's going to go up past the 0, come down at the 2, and then go up again. And again, acting just like a cubic function, positive cubic function. All right. So what happened there is we have something called, if we look back at it, it went up here, and we have a maximum here, right? We have a maximum up here. We have a minimum down here. And then it goes on this merry little way. When we have multiple maxes and mins, we call these either a local maximum or a local minimum, or a relative maximum and a relative minimum. Meaning it goes up, it comes down. When it goes up and down, it's a relative max, right? This is the top. When it comes down and goes up, this is a relative min, or a local minimum. Essentially, it's the turning points of the graph. All right. So here they have a function here, and they want us to find the local max and minimum, or the relative max and minimum. So it's the same function right here. And we have a max, a local max, or relative maximum at negative 0.865. And then we come down here, we have a local minimum at 0.642. All right, this problem. This is a dimension problem. And here it says to define a variable x. Or it says we have looking at the question, a digital box that maximizes the volume of while keeping the sum of the dimensions at 6 inches. If the length must be 1.5 times the height. Okay. First things first, it says volume. So I know volume is equal to length times width times height. That's my first equation. My second equation is they give me that the sum of the dimensions have to be 6 inches. So the sum, whatever it is going to equal 6. So it's going to be 6 equals length plus width plus height, the sum of the dimensions. And then we also give us a third dimension, 3 unknowns, 3 equations. And the third equation is they tell me that the length must be 1.5 times the height. So length is 1.5 times the height. And they want me to find what the dimensions are. So the first thing we have to do is sort of find out what each one is so that we can set up their volume. So first thing we're going to do, we already have one of the equations. Length equals 1.5 h. So now we just have to find the rest. I look at 6 and I have looking at this equation. And I can say and replace L with 1.5h. So I can say 6 is equal to 1.5h plus h plus w. So I already have this solved in terms of h over here. So this is 2.5h plus w. So I can solve in terms of the width in terms of height. So I'm going to subtract the 2.5 from both sides. And I have w equals 6 minus 2.5 h. So that's my second equation. I have the width in terms of height. I substituted L into here. I substituted this for L right here to get that. I combined it and then got what W is. Okay, so that was my first step. Now that I have everything in terms of height, I can find the volume to get an equation. So volume is equal to length times width times height, but we have length and width and height. So it's going to be 1.5 h times 6 minus 2.5 h times h. I do the math, and I get what the book says right here is negative 3.75 x cubed plus 9 x. So this is a squared. This is a, not xh, cubed plus 9h squared. Okay, so this is a cubic function, and they have it here. The reason why we need the function is we need to find the maximum, the local max or the relative max. By finding the local maximum, this says that this is the maximum amount that the height can be in order for me to plug it in and find out what the others are. So if I know that the maximum height in this case is 1.6, I can plug it into my equation and I can get the height, the length, and the width thereof. So for part 3, since I know that the maximum height has to be based off of the graph, actually part 3 is the graph, find the max, then part 4 would be to plug it in to find the length and the width. So this is the maximum height that it can be. So I plug in the maximum height that it can be, then I get the maximum length. I plug in the maximum height that it can be, and I can get the maximum width. So this would be for length 1.5 times 1.6, and then for I think is 2.4, the width would be 6 minus 2.5 times 1.6, which gives you 2. And then the height's already given as 1.6. So my dimensions are 2.4 by 2 by 1.6. The maximum height, the maximum length, the maximum width. Okay. This got it 6 does the same exact thing, but only with a different number. Instead of it being 6, it's going to be 4. So, I mean, it's like doing the same exact problem again. So, I'm not going to do that. Alright. Yeah, that's that section. Hope you guys have a great rest of your day.